Welcome back to another set of videos by the Pokemon Math Professor. Today we're going to be looking at concepts related to systems of equations. So things you probably would want to know before you start going into a unit based on that. So we're going to be starting by how do we check for equivalent equations? So let's think back to the word equivalent. This probably isn't the first time you've heard this word before. Do you remember what that means? In math, equivalent means things that are equal in amount, value, function, or meaning. And it is that meaning that we're really going to pay attention to as we check for equivalent equations. Now, to understand equivalent equations, we have to start by looking at the multiplication property of equality. So if we start with an equation like x equals 2, the multiplication property of equality says we can multiply the same thing to both sides and we will still have equal sides. So I'm going to multiply both sides by 2 and I get 2x equals 4. This means that x equals 2 and 2x equals 4 are in fact equivalent equations. So what that means for us is when we're checking for equivalent equations, we are looking for the number that has been multiplied to both sides of the equation so that we can have equivalent equations. Let's take a look at that. So here's our steps for success. We are going to use ratios. Now ratios are a great way to look for any sort of dilation or any sort of multiplication that is occurring between two things. And we're going to make sure that we are matching up corresponding coefficients and our constants from those equations. We may need to simplify those ratios so that we can then check to see if all of our ratios from the equation are in fact equivalent. And if they are, then that means the equation as a whole is equivalent. Let's take a look at this. So we have two equations, 4x plus y equals -1 and 12x plus 3y equals -1. Let's start with the coefficients of x. Now, technically you can set up these ratios in any way, but I try to be consistent so that I'm doing the same thing every single time I try to solve these problems. That way I don't have to remember 2 or 3 different ways of doing things. So I always take the second coefficient or the coefficient from the second equation and put it on top of the coefficient from the first one. In our case, that would be 12 over 4. Now this ratio, 12 over 4, can be simplified to become 3. Now let's do the same thing for the coefficients of y. In this case, we have 3 over 1, which can also be simplified into 3. Now, don't get caught in a trap here. You've now checked the coefficients of x and y, and you're like, yes, they are equivalent. But you can't stop there. There is still a third ratio we have to set up, and that involves the constants on the right side of the equation. And when I set up a ratio of those two, I get -1 over -1, which equals 1, which is not the same thing as 3. So because the 3 ratios are not all the same, these are not equivalent equations. Let's look at one more example. -25x plus 5y equals 25 and -5x plus y equals 5. Let's start with the coefficients of x. And again, I'm going to do the coefficient on the second equation divided by the coefficient on the first one. So that gives me -5 over -25, which simplifies to 1 over 5, or 1/5. Now the coefficients of y. When you don't see a coefficient, like in the second equation with that y, then we always know that if it's an invisible coefficient, that actually means a coefficient of 1. So we're going to end up with a coefficient of 1 over 5, which is equal to 1 over 5, or 1/5. Finally, we got to check those constants. So in our case, it's 5 and 25. So 5 divided by 25 is equal to 1/5. So in this case, all three ratios do in fact equal the same amount. And because all three ratios equal the same amount, these are in fact equivalent equations. So, to sum up, it's equivalent ratios that help us check for equivalent equations. And if you set up your equivalent ratios correctly, there's no reason you shouldn't be able to figure out if those equations are in fact equivalent. As always, thanks to Slides Go for helping me create my slides.